Hello to another episode of the R&amp podcast. I'm Craig Eason, owner of Fathom World and host of this podcast. I'm an independent voice in the shipping space, having started in it over 35 years ago. This is the podcast from Fathom World looking at the changing technologies, people and environment of the seas. And both Fathom World and the podcast rely on advertising and funding to remain independent. So if you like what we do, if you like what you hear and want to help us create more, please get in touch. Now on with the show. Back in 1992, I was listening on the BBC World Service while out on a ship somewhere about the Earth Summit in Rio de Janeiro. Now, two topics in those talks were, of course, global warming, as it was called then, and biodiversity loss. The latter included concerns about the oceans and the risk of aquatic invasive species that could come from one region to another, gain football, and frankly wreak havoc environmentally and economically. Even back in 1992, and that was 30 years ago, it was already identified that shipping was a major way that this was happening. These invasive species came from ballast water, but they also came from fouling on ships' hulls. Our, and by this I mean the industry's ability to tackle this, was frankly awful. I'll not get into the Ballast Water Convention of 2004 here, just to say that even today it still has many critics about its effectiveness. But that's not what this episode is about, because an even bigger problem exists with biofouling of hulls, propellers, rudders, and the so-called niche areas around a ship's hull where species can live and hitch a ride to new habitats. Invasive species have been known to wreak havoc on aquaculture industries, to create economic problems in ports, and to have severe impacts on sensitive bioregions. But hull fouling also creates a huge cost to ship owners, and a new report from the IMO, from the Glofouling initiative, reveals just how much of a problem. There are no regulations on biofouling cleaning. There are on hull coatings, which are used to reduce growth on the hulls, with certain chemicals being banned or restricted due to their toxicity and environmental risks. But there are IMO guidelines on cleaning, which have unfortunately largely been ignored. So how can shipping take biofouling seriously and reduce the risks of invasive species? The answer is, of course, in the details of that new report that shows that fouled hulls can increase ships' fuel consumptions by double-digit percentages, and considering ships largely use fossil fuels, that adds to emissions. This increase in fuel consumption and CO2 emissions is potentially huge. Now, there's a piece of legislation that anyone in shipping knows is about to come in force and will hit the industry next year. It's the Carbon Intensity Indicator Rating, or CII, which will be a kind of A to E assessment of a vessel's performance. The CII rules mean any vessel getting a D rating for 2 years in a row or getting an E rating for just 1 year needs to take corrective action. It's already creating scares, with experts predicting a need for slower speeds, thus more ships, of shorter port stays, of adding fuel-saving technologies and putting vessels on new routes. And it's worth remembering the IMO's aim is to tighten this rating criteria regularly, forcing ships to be cleaner year on year. I was invited by the International Maritime Organization Secretariat to moderate a recent Glofouling R&D forum. It was a 4-day intensive deep dive into how invasive species and biofouling impacts shipping and other ocean industries around the world. It looked at the existing guidelines, the soon-to-be completed revision of the guidelines, and what measures countries, ports and others, including aquaculture industries, offshore energy companies and other industries, can reduce their risks. It brought in policymakers, ports, equipment makers and scientists from around the world. There were ship owner representatives there, but only a few who wanted to see what could happen in the future. Now, one representative owner was Martin Kopka, environmental manager from the container liner Hapag-Lloyd, and currently on secondment at the Maersk McKinney-Muller Centre for Zero Carbon Shipping. He explained to me why he sees the link between biofouling and the CII as a key worry.
It's even the differentiator between the D and the B, probably. So my professional life, I was in energy efficiency. And when introducing a very structured program to Hapag-Lloyd on hull performance, monitoring, and countermeasures, we had a lot of discussions with our charter owners for premium paints, for premium dry dock treatments, meaning a full blast rather than a spot blast. And we can measure the difference. It's huge. And over the 5 years of class cycle, the vessel is 5 years in a row in the water. There is fouling, there is degradation on the paint. And we can measure the difference. And it's 20-30% in consumptions. This is evident out of the numbers we have from 250 ships which we operate. We see those on a daily basis. This is a sophisticated task to analyze all those data, to correct wind, weather, drafts. But if we've done properly our homework, we see that, we prove that, and that's how we do our decisions.
Martin Kopka from Hapag-Lloyd. Now, the answer to getting better efficiency is clearly having clean hulls. But here's the catch. The traditional way to clean a ship's hull is to order a diving team to come and start cleaning a vessel at anchor or alongside in a port. That's dangerous work, and I've been told of divers being killed while spending hours using huge cleaning machines on the massive sides and bottom of the world's fleet. The response to this has been hull cleaning robots that can be controlled from the shore using umbilicals. But with both divers and robots, there's still the environmental problem of all that fouling falling into the water while the hull is being cleaned, and that means the potentially invasive species. This is why some of the cleaning robotics that have emerged have also come with collection of the biofouling, sucking the waste ashore, filtering it out and disposing of it. The port of Antwerp-Bruges in Belgium is one port that will let ships clean their hulls, but not by just any company they want to get to do it. Luc van Espen from the port tells me the approach for the 4 Flemish ports of Antwerp-Bruges, Ghent and Ostend.
So we allow in-water hull cleaning of fouled vessels under the condition that it's performed by a service provider that has a permit for that. And these service providers can only get a permit if they prove that they perform these operations in an environmentally sound way. That means that they have to prove that they have a sufficiently high capture efficiency and a sufficiently high filtration efficiency of the debris which is taken off the vessels. We organize tests for that before granting the permit, and that consists of 2 phases. The first phase is on a laboratory scale, in which we do a test in a 1 cubic meter of water, for example, and where we test these performances that we ask for, so the sufficient, the 90% capture efficiency and the 90% filtration efficiency. So that's the first phase, and once they have succeeded in that step, they can get to the second phase, which is in dock water, where we also perform a test with sampling and so on, and analysis. We are present there ourselves too. For example, there are samples taken around the ROV in order to detect whether there are spillage losses or not. And furthermore, we also take samples from the inlet and the outlet of the filtration installation in order to see whether the filtration efficiency is high enough.
Luc van Espen from the Port of Antwerp, talking about the approach that Flemish ports take, allowing vessels to clean the hulls while remaining efficient. While cleaning hulls does remove hull fouling and reduce the risks of bio-invasions and improve fuel performance, there's also that risk that cleaning can rub off some of the hull coating. Hull coatings are not only expensive but surprisingly complex in their design. They're applied in layers and can include biocides, even plastics and metals to keep the hull smooth and effective. These can be pulled off with cleaning, particularly abrasive cleaning, and this is also a worry for the ports and harbours and the environmentalists. It's another reason, say some cleaning experts, to collect as much as possible of what is removed from the hull and dispose of it ashore. At the IMO, and helping the Globalis team with its approach to biofouling and guidance to member states, is the Glofouling GIA, a global industry alliance. It's a collection of 11 companies and organisations that help the Glofouling work in its approach to aquatic invasive species. During the R&D conference, it announced that it was in favour of hull cleaning with capture rather than cleaning without. The GIA chairman is currently Yusik Kim, who's also head of one of the in-water cleaning companies in South Korea called TAS Global.
There isn't any technology which doesn't damage at all. Every technology has some kind of damage, but the degree of the damage is differences. Yes, there are some technology. Still, it's if you calculate it with just simple mathematics, it could be a bag, it could be some kilograms of microplastic. But still, these technology only takes up about 5 to 10% of the whole roll. Still, the 90% of the cleaning is done by divers with the plastic disc circulating like 1,000 RPM. That definitely does more than 50 to 100 micro peel off.
Now, the announcement from the GIA did ruffle a few feathers because nearly all the hull cleaning members of the GIA offer in-water cleaning with capture. But there's a lot of other companies with robot solutions that do not capture the waste collected off the hull, but some of these are not designed to clean heavily fouled hulls. That's not their purpose. In the biofouling publication recently released by the IMO that I mentioned, it shows that even a film of slime on the hull can have a significant impact on fuel performance. Cleaning the hull before it gets seriously fouled to remove this slime is the way forward, says Rune Skarbo from the Bologna Foundation, who's in charge of the Clean Hull initiative, which is promoting regular cleaning.
Basically, we are, through this initiative, focusing on keeping ships' hulls clean, and believe that proactive cleaning specifically is one of the kind of emerging tools that should be more in use in order to reduce the environmental impact from the shipping industry, in terms of both reducing emissions and potentially also reducing the risk of transfer of invasive species. I know that there's a lot of voices that are driving towards saying capture only, and I don't want to rule that out, but I also want to keep the possibility open that if the scientists and these smart people that are working on this are saying that it's possible to do it without capture, I believe that will allow a different set of technologies that will be, let's say, less complex and more available, and actually make the services more available to the industry to use. So it's a matter of course, if you're going to clean more frequently, the cost of each operation needs to come down compared to the more heavy-duty cleanings with collection and the big containers and the big, impressive ROVs, right?
Rune Skarbo from the Bologna Foundation on the Clean Hull initiative. And the issue of niche areas came up time and time again during the R&D summit, because no robotic hull cleaning system can really effectively clean the sea chest around the rudder stock or inside a bow thruster grating, for example. This is why discussions also looked at solutions such as ultrasonics, ultraviolet light diodes in those areas, and other advanced fouling release systems. But back to hull fouling. While companies such as EcoSubsea, Hull Wiper, Clean Subsea and TAS Global have developed solutions to clean heavily fouled ships and collect the debris quite effectively from the cleaning, companies like R&amp Robotics in the US have grown out of naval work and the desire to keep hulls efficient and clean. Carl Lander from R&amp was one of the panelists during the forum.
We are a non-collection type system, and we've opted to go that direction because our approach is to be on the hull frequently and habitually, never allowing the fouling to develop past the biofilm slime stage to get to anything that we believe needs capture. Ultimately working on a concept that's been coined previously called groom before you go. And the idea is if you leave one port with a clean hull, anything that collects on the hull in a direct transit to the next hull is going to be extremely low risk. It's going to be minimal amount of material, first off. And then second, it's not going to be a biosecurity threat in that next port, and continually keep the hull clean, improving your fuel consumption and not posing any additional environmental risks. There are ports that right now are mandating only collection, but they're mandating collection with systems of 90% efficiency. And so they're allowing some amount of material to be let into the water. And we believe the science is going to demonstrate that a proactive cleaning approach is still better for the environment than a reactive cleaning that misses something. And many ports are still very open to just are not requiring anything. And so we have the opportunity to prove the technology as we tighten and should tighten the regulations worldwide to improve the environment.
So what approach should ship owners and operators take? Well, there is another catch in this, and this is the charter agreement between owners and operators, where an owner may be responsible for cleaning and the operator for the fuel costs. I was told at the forum that this has been looked at in the past, but has so far failed to be fully resolved. It is hoped, however, that ships going from B to D on the CII rating because of fouled hulls may be the incentive for owners to take the issue more seriously. Here's Martin Kopke again from Hapag-Lloyd and why he thinks they will.
We need to understand that hull performance and hull management is one of the key levers to pull for decarbonizing our industry. When we look at new fuels, at alternative fuels, they have a long way to go that we can produce either green fuels or that the regulations are in place. So what's left in the time between is energy efficiency. And there the hull performance is a huge contribution. And I'm happy to see that the IMO is addressing that with a 2-digit percentage number what we can reduce by having cleaner hulls. With regard to the technology, we as a ship operator are technology agnostic. We will comply with regulations. Nevertheless, we say when we think about grooming, and we know having a clean hull is an efficient hull. And there are a lot of numbers out there that even some slime is 10% more consumptions, and container ships burn a lot of fuel. This we want to avoid, and we want to keep clean hull. And grooming at a very early stage without capture, we think it seems to be a very good idea. Of course, in the end of the day, we rely on the scientific results, and we'll of course comply with that.
But the ability to either groom or do proactive cleaning, as it's sometimes called, will obviously depend on the ports and member states taking an approach. Luc van Espen from the Port of Antwerp, Bruges, on why the revision of the guidelines should lead to something more mandatory to help the threefold risks of biofouling. That's obviously aquatic marine invasions, increased CO2 emissions, and those plastics and metals that could come out in harbour waters.
We are happy to see that there is revised guidelines and that this will lead to a kind of international standard on hull cleaning and propeller polishing. We hope, first of all, that this will stimulate the ship owners and the ports to apply this standard by seeing the good examples of other ports and other ship owners. Maybe it would lead to a mandatory guideline, like you say, the ballast water convention. Certainly, if not everybody is going to apply this spontaneously. But maybe you can start with a voluntary application, also to build up, let's say, experience with the application of the guideline. But I think in the end there will be a mandatory aspect on this.
Luc van Espen from the Port of Antwerp, Bruges, on the hopes for something mandatory for biofouling in the future to help create clarity and certainty. So what do you think? More guidance and let the CII build up interest in biofouling response and CO2 reductions, or a mandatory tool to help reduce the risks of marine invasions and the negative impact on biodiversity? That's it for this episode of the R&X podcast. My name's Craig Eason. I'm the editorial director of Fathom World, the news site focused on the sustainable development of the shipping and ocean space. Please consider subscribing to the Fathom World newsletter, and of course, like, follow and share this podcast, and get in touch with me if you want. Until the next time, goodbye.